All right, today we're going to be talking about division properties of exponents. All right, and the rule here, to divide powers, with the same base, subtract the exponents. All right, when you multiplied powers with the same base, you added the exponents. And when you divide powers with the same base, you subtract the exponents. So if you have a to the m power divided by a to the n power, that would be equal to a to the m minus n power. And what that looks like with some numbers is if you had 2 to the 6th divided by 2 to the 2nd, that would be equal to 2 to the 6 minus 2 power, which is 2 to the 4th power. And then I said yes the other day that the 4th power and less, we're going to evaluate it. So in your calculator, your 2 raised to the 4th equals, and that's 16. All right? When you're dividing exponents and the bases are the same, you subtract the powers. So if we got x to the 4th divided by x to the 7th, that would be equal to x to the 4 minus 7, which is now x to the negative 3. And remember, when you're dealing with exponents and you're writing expressions in their simplest form, you can't have a negative exponent in your answer. All right, so this becomes 1 over x to the 3rd. If you had s to the 3/4, and you're going to divide it by s to the 1/2. All right, same rule. That would be equal to s to the 3/4 minus 1/2. All right, which would be equal to 3/4 minus 1/2. That would be s to the 1/4 power. All right, just subtract if the bases are the same and you're dividing exponents, subtract the powers. And make sure you do numerator minus denominator. All right, it's always numerator minus denominator. All right, if we got k to the 6th, j to the 2nd divided by kj to the 3rd. All right, you got k to the 6th divided by k. So we got k to the 6 minus 1 power. Don't forget about this first power right here. It's not written, but it is implied. So we got k to the 6 times k to the 6 minus 1 times j to the 2 minus 3. So we get k to the 5th times j. 2 minus 3 is -1, so we got a -1 right here. Now we simplify that. We got to have all positive exponents. So our k to the 5th stays in the numerator. And our j to the -1, that goes to the denominator, and you don't write the power. All right, j to the -1 is the same as 1 over j to the 1st, but you don't write anything to the 1st power. Let's look at a to the -3rd, b to the 7th, and that's going to be divided by a to the 5th b squared. So let's deal with the a's first, and we get a to the -3 minus 5 times b to the 7 minus 2 power. So our a is now raised to the -3 minus 5, that's -8. And our b is to the 5th power. And then to finish this, the a to the -8, that has to go to the denominator and become +8. And since the b is already raised to a positive power and it's in the numerator, it can stay in the numerator. So there's your simplest form. X to the 4th, y to the -1, z to the 8th, divided by x to the 4th, y to the -5, and just z to the 1st, but we don't write the 1. All right, so what this becomes is you got an x to the 4th divided by an x to the 4th. So that's x to the 4 minus 4. You got y to the -1 minus -5. And then that's times z to the 8 minus 1 power. So when we simplify all of this, x to the 4 minus 4, that's x to the 0. Y to the -1 minus -5, so that's -1 plus 5, so that's y to the 4th. And our z is raised to the 8 minus 1 power, so that's z to the 7th power. So now if you remember from last week, anything raised to the 0 power is equal to 1. So this x to the 0 power just kind of goes away, all right? And what you're left with is y to the 4th, z to the 7th. Y to the 4th, z to the 7th. All right, so everybody good on dividing exponents? Just subtract the powers. Subtract the powers and try to stay organized, okay? Remember that anything that doesn't have a power is to the 1st power. And anything to the 0 power just equals 1, all right? And you don't have to write anything. All right, so in the second part of your lesson today, is where we are going to raising a power to a power. Raising a power to a power. And here's what that looks like. that would look like a to the m all raised to the nth power. All right? That's called raising a power to a power. When you raise a power to another power, you multiply the powers. All right? When you raise a power to a power, you multiply the powers. So this would be a to the m times n power, which is equal to a to the mn power. All right? When you're raising a power to a power, multiply the powers. So x squared, all raised to the fifth, that's equal to x raised to the 2 times 5 power. And that's x to the 10th power. P to the fifth raised to the fourth, that's equal to p to the 5 times 4 power, which is p to the 20th. All right, and then you'll have problems that are a little bit more complicated, but not too much. Here we got y to the third times let's see if we got y to the second raised to the negative fifth. All right, so what we got here is we got y to the third times y to the second power raised to the negative fifth. So that's 2 times negative 5 as an exponent. So that gives us y to the third times y to the negative 10th. All right, now, if you remember from Monday, when you are multiplying, when you're multiplying powers and the bases are the same, you add the powers. All right, so this becomes y to the 3 plus negative 10, which is negative 7. So all of this simplifies to 1 over y to the 7th. All right, so you had to take a power raised to another power, and then you had to multiply powers with the same bases. So you had to combine a couple of different rules in the same problem there. All right, just like if we had x squared, and it's multiplied by x to the 6th raised to the negative 4 power. So what you end up with is x squared times x to the negative 24th. And now your bases are the same, so you're going to add the powers. So you've got x to the negative 22nd. And then in simplest form, that becomes 1 over x to the 22nd power. All right, then let's take a look at if you've got something like, let's say we got 4 x squared y to the third, all of it, the whole quantity raised to the 4th. When you have an entire quantity, or when you have more than one thing in these parentheses, you got a whole number You got a variable and you got another variable. And everything in there is raised to the fourth power, which means you need to distribute this fourth power to everything inside the parentheses here. All right. What this means is you got 4 to the fourth power times your x becomes x to the 2 times 4 power, which is the 8th power. And your y is to the 3rd power raised to the 4th. So that's y to the 12th. All right, so anything to the 4th power or less, we're going to finish it. So we got 4 raised to the 4th power. So we got 256. X to the 8th. Y to the 12th. All right, let's take a look at let's go n to the 1/2 raised to the 10th times, we got 4 mn to the negative 2/3, all raised to the 3rd power. All right, so just try to stay organized here. You got your n to the 1/2 times 10th power. All right, you're raising a power to a power here, so you got to multiply. So if you do 1/2 times 10, you get 5. So we got, to start off, we got an n to the 5th power times. Now this 4 has got to be raised to the 3rd power. So we got a 4 to the 3rd. Then we've got an m to the 3rd. And then we've got this n power. This n power is to the negative 2/3 power. So we got negative 2/3 times 3. So 2/3 times 3. That's negative 2. All right, so now what you got to do is clean this up. All right, we got a 4 to the 3rd. Our 4 to the 3rd becomes 64. Our m to the 3rd stays m to the 3rd. And our n to the 5th times n to the negative 2. All right, we got bases are the same and we're multiplying, so we're going to add those powers. So that's going to be 5. I'm sorry, that's going to be n to the 5 plus negative 2 power. That's going to be n to the 3rd power. So there's your simplest form of this right here. All right, does that make sense to everybody? The key, it's not difficult. The key is just staying organized. And what normally happens is people start off being really organized and then they start skipping steps because they don't feel like writing as many steps down. And then they get unorganized and they miss a step and they get a power wrong and the whole problem becomes wrong. So my advice to you would be to just stay as organized as you can. Take your time and do the extra steps to help stay organized. And then just be careful. And if you're careful, it's all simple and you should do really well. Got it? I think somebody was, what's going on here? Chat, love chat. Finally in. All right. All right, buddy. Welcome. Welcome to the jungle. Welcome to the jungle. Okay, so your practice for today is you got a packet yesterday, right? Did you get it yesterday? Bunch of stuff stapled together? All right. So we got page 436 today. (10 through 21). 436. And then 437. 22 to 33. All right, and then we got this division stuff. That's going to be 441. That's going to be 442. (8 through 23). All right, there's today's assignment. Do it on a sheet of paper. Don't do it on the handout that I gave you because then you pass it in. You don't have it anymore. So do it on a clean sheet of paper so you still got the handout to use tomorrow. Any questions? Yep, you're going to put it in the basket when you're done. So look, if you're kind of a person if you think that's a lot of work and you're not going to get done, then do every other problem, okay? Do every other problem, and then if you get finished with that and you still got a bunch of time left or you still got more than 10 minutes left, go back and do some of the ones that you didn't do. But at least you'll get exposed to all of the problems in the assignment and you'll get to practice all the stuff we went over today.